So Pete mentioned the engine being a very critical part of the launch vehicle. It is fundamental as part of developing the engine that we can test it. And typically that's something that takes a lot of infrastructure, a lot of capital outlay. And with that, today I'm excited to announce that we've selected the A3 test complex as the home of testing the Archimedes engine, like the example you see behind me here. This site was originally built to test engines much larger than Archimedes. And as you can see, it comes in with a mammoth of infrastructure, critical infrastructure like cryogenic systems, tanks, test systems, instrumentation bays, buildings, and a whole lot more that can be quickly adapted to support our engine test operations. Beyond the concrete and steel as well, this whole test site is about 1 million square foot in area. And more than just tanks and the actual hardware, it takes a lot more to get a test site online and running. By being in the Stennis facility, we can leverage a lot of their site-wide infrastructure, so power systems, transport network, commodity and supply chains, all the little things that make a test site run and tick. So we're really looking forward to stepping this up here. And typically, what would take in the order of years to set up a test site, we can now jump in here very quickly, modify some systems, and get testing in the span of months. And a few of the details with this test site that we've announced today. We'll have exclusive use of the entire land, as well as all the test infrastructure you see in the image there in that video before. And we'll have this for 10 years with the additional, or the option to extend it for another 10 in the life cycle of the program. I also want to probably shout out to the NASA Stennis Space Center, as well as the state of Mississippi, for not only welcoming us, but also putting forward a generous capital incentive and investment for us to be able to develop the site here very quickly. So all systems go for us at Stennis, and we're looking forward to breaking ground here very shortly and seeing some construction to modify this site, this historic site, to what will be a key part of history moving forward with testing the Archimedes out there. Looking out east as well, we continue to make great progress in Virginia, the Neutron factory. You might recall we broke ground at this site earlier this year, and it's been a hive of activity since. It was literally a greenfield when we started, but now it's been cleared, it's been graded. We're pouring our first concrete, and what you're seeing there is actually the site on which we'll be building our first stage 1 tanks. So that's something we're very much looking forward to kicking into later this quarter and into next year. The other thing I want to point out with Virginia and the uniqueness of this is the fact that this is more than just a factory to start, it's a development site. It's an area where we can build the rocket but also test it in very close succession. All our test systems and test infrastructure will be co-located to some of the production facilities, and that'll really just help accelerate the timeline we've got here in front of us in developing Neutron. 2.5 miles from the Neutron factory is what you see here is the vision for Launch Complex 3. What you're looking at here is the art of the possible. It's a launch pad that, being in such close proximity to the Neutron factory, enables us to avoid all the painful logistics of moving a rocket that's 7 meters. You get a sense of scale here with the half section across transport ways and so on. So having the site co-located with production and launch really enables us to unlock all the constraints that typical rocket programs otherwise face. There's a reason why you find most modern launch vehicles being about a maximum of 3 meters in diameter. It's because they've got to go under a tunnel or a bridge somewhere across the coast. So this is a unique proposition that we have here with the launch pad and production facility of major functions being so closely located. But what you're looking at here is Launch Complex 3. And through our partners in Virginia Space and NASA Wallops Flight Facility, we have secured the land to locate this pad. So to give you a sense of scale, and those familiar with the Wallops Island, this pad is located between Launch Complex 2, which is currently the home of Electron from the United States, and Pad 0B there. And we've been able to secure the land to be able to move into construction here very swiftly. One of the key things with Launch Complex 3 that's been on the forefront of our mind is to have this operation be as slick and seamless as possible. So we've had an eye in all architectural decisions we've made to minimize the amount of infrastructure we need on the pad. Ultimately, that just raises the operating cost for a big system like this year on year. So that's been at the forefront. So the pad essentially features a static launch mount where Neutron will be vertically stacked. Surrounding it are some propellant farms and fluid storage that feed the launch pad and the launch vehicle. In the vicinity is a landing pad where you can receive a return to launch site return booster. But also what's unique about this is we've laying in the provisions here for seawalls to extend out to sea and essentially be able to pick up a booster off an ocean platform that returns from a downrange landing. So it gives us that extra performance here, all within the same capability. And finally, the big structure you see within place just behind the launch pad there is what we call the rollover structure, the rollover gantry. It's intended to effectively slide over the launch pad, support stacking of Neutron, specifically in adverse conditions, provide that extra and enhanced launch vehicle and payload protection that's sometimes required for certain missions. But also, ultimately, that structure is intended for us to be able to operate all year round in adverse conditions, so to be free of any launch availability constraints. And that same structure then is envisioned to come out to sea and then pick up the booster that's returned from a downrange landing, pick it back up, take it back to the launch pad, and set it down again. And ultimately, what this overall architecture really presents us is with, again, a slick and streamlined operations where we're not handling the vehicle multiple times, we're not transporting it through various phases in various parts of the country to get it back to the pad. Right. And part of the development program, I think, has also seen us have some critical customers onboarded relatively early in the program, and that perhaps speaks volumes to the credibility of the program we have here. Late last year, we signed a contract with the United States Space Force for about $24 million to develop the upper stage for Neutron, and also lay the foundation for us to on-ramp Neutron onto the National Security Space Launch Program. That is quite an important program for us. It is one that essentially showcases and features all of the nation's most critical space missions. And it's an honor for us to be on-ramped and to be able to on-ramp this early and be part of a program that helps us get there. We're tracking pretty well for our period of performance so far. We've had our key milestones delivered, and we're looking well to complete this entire contract award by the end of next year. In addition to the Space Force contract, we've also signed a cooperative research and development agreement with the United States Transportation Command. And this is to really explore using Stage 1 as a point-to-point delivery mechanism. You've heard from Pete before. Stage 1 has a whole bunch of energy packed into it. It's capable of lifting a sizable Stage 2 and then precisely land onto a target. Kind of all the key ingredients you need to deliver point-to-point cargo. And we're really excited to see Neutron being showcased in this capacity as well. And yeah, finally, before I wrap, there's a lot we've updated you on today, but I do want to convey as well that the team and I are focused on getting a vehicle to the pad in 2024. But I do want to emphasize that we're not starting from scratch. We've got a compressed schedule in front of us, but what makes this happen is that we have a strong team that's coming off the Electron program, a wealth of technology that scales really well from a small rocket like Electron onto Neutron. To put this in perspective, a flight computer sitting inside Electron is about the same size as it would be in Neutron. So just like that, a lot of technologies in avionics, GNC, software, telemetry, command and control, production processes that take a lot of pain to set up initially, all just translate across to Neutron. We don't have to do these things from scratch. We simply leverage the team we have, the technology we have, and pour it over to the bigger rocket. And what you've seen today, too, is we've secured the large amounts of capital we need and the infrastructure we need to get our test sites and launch sites underway. That really lays the foundation for us to go forth and execute on the rest of the program.